Hello, my name is Ashok Goel. I'm a professor of computer science here at Georgia Tech. I'm also the director of the Design and Intelligence Lab. We recently developed a new interactive technology called DANE, where DANE stands for Design by Analogy to Nature Engine. To explain DANE, I'll begin by asking you a question. Imagine that you are living in a desert country, let's say Namibia, a country in southern Africa, and there was an acute water shortage. How would you provide water to the people living in a country like Namibia? Well, we can come up with many solutions. We could, for example, port good water from different parts of the continent to Namibia. This is possible in principle, but it's very energy efficient and it's very costly. It turns out that nature has some beautiful, amazing solutions to problems like this. Inside Namibia lives a small organism called the Namibian beetle, which has the same problem of surviving in a place of acute water shortage. So the Namibian beetle on its back has hydrophilic and hydrophobic surfaces. Hydrophobic surfaces repel water. Hydrophilic surfaces attract water. These are nano bumps on the back of the Namibian beetle. The hydrophilic bumps attract water from the fog that comes in a breeze about 6 times a month. So when the breeze comes, the Namibian beetle positions itself and the water is extracted out of the fog. And the hydrophobic surfaces make sure that the water doesn't spill over and it's channeled into the beetle's mouth, and that's how the beetle survives. What a beautiful solution for a very complex problem. Why cannot humans do it? In fact, recently humans did exactly the same thing. They created their own fog harvesting devices using exactly the same design pattern. So why did we not do it 10 years back or 100 years back? Part of the reason was that we did not have access to biological knowledge in a language that engineers could understand. This is where computing can help. This is where our technology can help. So here is the interface to the DANE system. On the left-hand side, over here, is a library of biological systems. This library contains biological systems all the way from the level and scale of ecosystems, which are often kilometer long, to the level of molecular systems, which are much smaller. Consider now the one about the Namibian beetle that lives in the Namibian desert. Here are some photographs. One can enlarge the photographs. So here is a photograph, for example, that shows that the water droplets are getting formed on the back of the beetle. We can go into a model view, and this model view has a more systematic representation of the kind that engineers understand. Here in the behavior part is something about the mechanism that results in that function, and we can again go to a more systematic representation of the mechanism so that engineers can have a detailed knowledge of how that system works. We can go back to knowledge about the structure, and we can navigate through any of these systems that are in the library. We are constantly adding more systems. Currently it has about 50 to 60 systems in it.